Hello, good morning. I'm discussing transmission electron microscopy (TEM) is a technique of imaging the internal structure of solids using a beam of high energy electrons transmitted through the solid. Transmission electron microscope was the first electron microscope that used a high energy electron beam to generate morphology, composition, and crystallographic information. Morphology, composition, and crystallographic information of given sample. Principle of TEM. Electrons are passed through the sample or specimen or image and gives the ideas about the internal structure of the sample. Electrons transmitted through the sample will strike into the fluorescence screen plate and it will be converted into image, which is 2D or black and white. Electron gun is used to produce the electron beam and operated at 1 to 30 kilovolt and 80 to 300 kilovolt. The tungsten filament is used in the electron gun, which emits the beam of electrons at very high voltage. This is the instrumentation, electron source, condenser lens, sample, objective lens, intermediate lens, projective lens, fluorescent. Once the electron microscope interacts with the specimen, they are either scattered or transmitted based on mass and density ratio. The transmitted electron beam will strike the fluorescent screen or the charge-coupled device camera, which will generate an image with varying contrast based on the intensity of the electron beam. Components: electron gun. The tungsten filament is useful for production of the electron beam in the electron gun. Condenser lens. These are electromagnetic lens and they will focus all the electron beams toward specimen sample. In TEM, number of condenser lenses are more higher compared to the same. So electron beam will more accelerated and it can easily penetrate specimen. Objective lens, it is also an electromagnetic lens and focus for the transmitted beam toward the projector lens. Projector lens, it will magnify the transmitted beam coming from the fluorescence screen or charge coupled detector, which will send the data to the CPU. The TEM is operated under vacuum to reduce any kind of interference by air. Sample precision fixation, ultralight chemical fixation, liquid neon or helium gyrofixation, ranging sodium cacodylate secondary fixation, osmium tetroxide, dehydration ethanol or acetone. Fixation, chemical fixation, gyrofixation, ranging secondary fixation, osmium tetroxide, dehydration. TEM can operate on two modes, diffraction mode. The objective lens forms the diffraction pattern in black focal plane with electrons and scattered and diffracted by the sample and combines combines them to generate an image in the plane image. The objective lens forms a diffraction pattern in black focal plane with electrons scattered and diffracted by the sample and combines with the generated an image the plane. The objective lens forms a diffraction pattern in black focal plane with electrons. Diffraction can identify whether the sample is single crystalline, polycrystalline, or amorphous by taking the selective diffraction. The single crystal produces diffraction pattern consist with center spot associated with the transmitted beam and other diffraction spot. Polycrystal produce diffraction pattern on the ring of different radius. Amorphous sample follows the halo rings pattern. The single crystal, polycrystal, the amorphous. Image mode. Image of the sample is focused and projected onto the screen, which are two types as follows. Bright field image. It is often transmitted to the objective aperture. Dark field image. It is often always diffracted beam to the objective aperture. Bright field image and dark field image. Difference between CHEM and TEM. CHEM shows only the morphology of sample. TEM can show many characteristics of the sample, such as internal composition, morphology, and crystallization. CHEM can resolve objects as close to 20 nanometer. TEM has much higher resolution than CHEM. It can resolve the objects to close 1 nanometer, that is down to near the atomic level. The magnifying power of CHEM is the 5,000 and the TEM up to 2 million times. CHEM also for large amount of sample to be analyzed at a time. With the TEM, only small amount of sample can be analyzed at a time. Secondary or backscattered electrons arising from the interaction of electron beam and metal coated specimen are collected and resulting image is displayed on computer screen. Same electrons is fluorescent, hit on the fluorescent skin, giving rise to the shadow image and specimen with its different parts displayed in varied darkness according to their density. The image can be studied directly by the operator and photographed with a camera. Advantage of TEM, less sample is required. TEM provide information on element and compound structure. TEM are able to yield information of surface features, shape, size, and structure. Some disadvantage: high vacuum is required. TEM are large and very expensive. Laborious sample preparation. Information that can be obtained from TEM: the shape, size, and organization of the nanoparticles, that is morphology of sample within a thin sample at atomic scale resolution. Crystallographic resolution, such as degree of crystallization or ordering of atoms, symmetry, and atomic scale defects in localized area of sample using electron diffraction mode TEM. Elemental composition information and their ratios from localized domains of size of few nanometers when operated spectroscopic mode. Okay, it's all about transmission electron uh, microscope. Thanks for watching and Request you all like, comment, share, and subscribe. Thank you for patient. That's now. Bye bye.